Okay, so we are going to do some lessons today. The material we cover today is not going to be on your test that is on Thursday. Okay, so your test 1 is this Thursday, the 15th. It's going to cover lessons 1 through 13. Okay, so basically everything before today. 1 through 13. That's up through the word problems where you had to use the little table, set up 2 equations and 2 unknowns. Okay, everything up till there. So just to remind you of the resources you have available for tests, I'm just going to quickly go to Moodle. And show you, remind you what's in there. Okay, so packet 1 is everything that the test is on. It's on everything from packet 1. So you have a blank packet 1, and then this is an annotated version, which is everything that I wrote on the board. Okay, so you can see that this is sort of like the filled in notes. So if you're missing any days of notes, you can go here as you're studying. If you missed any classes, there's videos from each class. And then for quest and test material, there are the practice problems, the practice problems packet. If you already did these when you were preparing for the quests, I would suggest do them again, right? You can get a blank version of this on Moodle so that you could just redo them. Probably you won't remember them from the first time, right? And also in your homework, you can always go into any homework and all of the questions have the try a similar problem button. So you can do lots of extra practice there. What? It will never lower your grade. I have it set to give the like best response. Yeah. And then if you're trying to work through these practice problems and you're stuck, there is another file called solutions. And this has all the work shown out to come up with these solutions. And then also, if that's not enough, you can click on the solutions videos and it takes you to a YouTube playlist. And let's say you were stuck on practice problem 5, you just click it and it has a video of practice problem 5 being solved. And in addition to all of those resources to help you prepare, you can also create a one-page sheet of notes. You can put whatever you want on it, front and the back. The only stipulation is you have to create it by writing or typing it yourself. Okay. No cell phone pictures or photocopies of notes or somebody else's sheet. Write it or type it yourself. All right, questions about the test. We'll have about 30 minutes before you take the test on Thursday as review time. I think it seems to work better doing that sort of individual review, and I came around and answered questions rather than me at the board because it just takes a little bit longer and you don't get exactly what you needed to study. So I think we'll do the individual sort of study time and then take the test. All right, so let's look at what we talked about last class. Again, just to remind you, this is not on your test on Thursday. Okay, this is the start of a new unit. So first we talked about the Pythagorean theorem, which deals with right triangles. When you have a right triangle, if you square each of the legs, which are the sides that are touching the right angle, square each of the legs and add them together, it always adds up to the hypotenuse squared, and the hypotenuse is the side opposite the right angle. So we solved a little word problem that involved the Pythagorean theorem. And then we started talking about exponents, right? Because the Pythagorean theorem introduced this idea of squaring. And we moved on to exponents. And we talked about the definition of an exponent being repeated multiplication. And the fact that that definition can help you figure out the 5 laws, right? So at some point, you might skip using the definition and you just have the laws memorized. But you are never required to do that. You can always figure out what the law is via the definition of an exponent. So for example, the rule, the law, is that if you multiply two exponent, if you're multiplying two terms, two factors, and they have the same base, right? So in the definition here, we have x is the base in both of these, and they have different exponents. You can rewrite that as x to the m plus n. So if you're multiplying like bases, you can add the exponents. If you're dividing like bases, you can subtract the exponents. If you're raising a power to a power, x to the m to the n, you can multiply the exponents. And we did examples of each of these, writing out the definition, why it works. When you're taking a product and raising that product to the power, it looks like the distributive property, where you take that m and you can sort of distribute it to the x and to the y, to each factor. Okay? And the same thing with division. If you want to take a fraction and raise it to a power, you can raise the top and bottom to that power separately. So those are the main rules. And negatives and exponents together is the trickiest. And I think most people stumbled most over this one. And I thought of another way to explain it. Another reason why that works. That says minus 4 squared. Think of that negative sign as a subtraction sign, right? Minus 4 squared. So if I wrote 0 minus 4 squared, what is that? Negative 16, because you got to square the 4 first, and you get 16, and then 0 minus 16 is negative 16. So hopefully that might help explain that, why that one is negative versus this first one. When the negative 4 was in parentheses, that meant negative 4 times negative 4. All right, and then in addition to the 5 laws, we talked about anything to the 0 is 1. Right, so for right now, this is just a random factoid in your brain. Anytime you raise anything to the 0, you get 1. Later in today's lesson, we're going to talk about why. Okay, so that's really important, why. But for now, just know that no matter how messy the thing is, right, if it gets raised to the 0, the answer is 1. All right, so I'm going to have you start with the activities on page 109, and we'll work on those for a little while before we move on to lesson 15. We're going to just continue talking about exponents, okay? So some of you asked me questions about negative exponents because when you were doing the rules in the last class's activities, you ran across some negative exponents. So today we're going to talk about why anything to the 0 is 1, right? And what negative exponents mean. Okay. So if you think about the definition of an exponent as repeated multiplication, raising something to the 0 just makes 0 sense, right? Raising something to a negative number doesn't make sense. So instead, we have to extend our definition of what an exponent means. All right, so here are some properties that we're going to look at. A to the 0 is 1. Anything to the 0 is 1. For example, 3 to the 0 is 1. So that's a property we already talked about. We're going to look at why in a minute. And if you raise a number to a negative exponent, that means take the reciprocal, flip it over, do 1 over that same number to the positive exponent. Okay. Or vice versa. If you have a negative in the denominator, you can move it up to the numerator and make it positive. So for example, 3 to the negative 2 is the same thing as 1 over 3 to the positive 2, or 1/9. And 1 over 3 to the negative 2, you can take that 3 to the negative 2, move it up, and it becomes 3 to the positive 2, which is 9. So let's look at a little pattern to see if we can figure out why this happens. All right, so 3 to the 4th, what is that? It's just a number. What does it equal? 81. 3 times 3 times 3 times 3. 81. All right, 3 cubed, that is 27. 3 squared is 9. 3 to the first is just 3. And then 3 to the 0, I cannot figure out as repeated multiplication. Because that means copy 3 down 0 times and multiply them together. Like, that doesn't even make any sense. So I can't use my regular definition of repeated multiplication. So I'm going to try to figure out if there's a pattern in these 4 numbers above it to figure out what might go here. So 81 to 27, what do you do to 81 to get 27? Divide by 3. 81 divided by 3 is 27. If I do that again, 27 divided by 3 is 9, right? 9 divided by 3 is 3. What is 3 divided by 3? 1, right? So if my pattern were to continue, I would get 1. Let's see what happens if I do it again. What is 1 divided by 3? 1 divided by 3 is 1/3. It's the definition of 1/3. What is 1/3 divided by 3? 1/9. If you took a third, chopped it into 3 pieces, it would end up being 1/9. Okay? And 1/9 divided by 3 is 1/27. And 1/27 divided by 3 is 1/81. So this is how we extend a definition. We started with a definition, meaning repeated multiplication. And then we said, okay, well, if raising to the 0 and a negative power is to make any sense at all, it's got to fit with the pattern of raising to positive exponents. So we looked at that pattern and we made it fit. All right, so x to a negative exponent is 1 over x to the positive exponent, and 1 over x to the negative exponent is x to the positive exponent. Okay. So here's a useful shortcut for negative exponents. Negative exponents indicate movement. Okay. If you see a negative exponent in a numerator, you can make that exponent positive by moving the entire term into the denominator. If you see a negative exponent in a denominator, make that exponent positive by moving the whole term up to the numerator. Okay, so a lot of students resonate with this crying baby analogy. So sometimes babies cry because they want to be picked up. And sometimes babies cry because they're tired and they want to be put down, right? So think of a negative exponent as a baby that's crying. So if the baby's in the numerator, it's being held and it's crying, maybe it just needs to be put down, right? So you would move it down to the denominator and it stops crying, you make the exponent positive. If you have a negative in the denominator, right, the baby's crying, it just needs to be picked up, right? Just move it up to the numerator, make the exponent positive. So let's do an example. This is kind of a complicated one because it has lots of factors in it. So hopefully we're going to deal with all the possibilities that can happen here. So I want to rewrite this whole expression so that it has no negative exponents. So first things first, deal with the parentheses. Just like with any simplification problem, you got to live by the order of operations, deal with the parentheses first. Okay. So this becomes 5r to the negative 9. I'm copying everything down. 25r to the negative 5, d to the negative 7. And then how does this simplify? D cubed to the negative 2. D to the negative 6, right? Raising a power to a power, you multiply the exponents. So that becomes d to the negative 6, right? All right, so now I'm going to deal with all the crying babies, right? Any exponent that's negative, I move it to wherever it needs to go, right? If it's already up, I move it down. If it's down, I move it up. Okay, so my r to the negative 9, so my 5 and my 25 stay where they are because they have exponents of 1, right? That's 5 to the first, 25 to the first. They're happy babies. Leave them where they are. My r to the negative 9, right? That's a crying baby. Move it down. It's got to go down for a nap. So you put the r to the 9th, r to the positive 9 in the bottom. Now the baby's happy, exponent's positive. All right, and then all these negative exponents in the denominator can get moved up to the numerator, making the exponents positive. So I have r to the 5th, d to the 7th, and d to the 6th. So all my exponents are now positive, and now I'm just going to simplify a little bit, right? So 5 over 25, that can reduce, right? How many times does 5 go into 5? Once. And it goes into 25 5 times. And then r to the 5th over r to the 9th, how does that reduce? R to the 4th, should I put it on the top or the bottom? The bottom, right. So when I do that subtracting trick, you can either do 5 minus 9 and get -4, right, which would go on the top. Or you can do the 9 minus the 5. I kind of like this rule where I always just do the subtraction in the order where I'm not going to get a negative answer. So the bigger minus the smaller. And you put the result where the bigger one was, right? Because picture what this means. This means 5 r's times each other on top, 9 r's times each other on the bottom. You're going to cancel. You'll be left with 4 of them on the bottom. So this becomes 1 and 5. R to the 5th over r to the 9th reduces to r to the 4th. And then d to the 7th times d to the 6th, what does that reduce to? Simplify to? D to the 13. There we go. So that one used a lot of rules. So you should notice that we didn't try to do too much in one step. That is my biggest piece of advice when you're doing these. Simplify one thing at a time. Apply one rule at a time. Right? In this first step, all I did was get rid of the parentheses. Right? Then I did all my negative movements. Then simplify. Right? And if you need to write out more steps than I did here, by all means, just write out every little step that you do. All right, scientific notation allows us to easily work with very large or very small numbers. We write numbers in this format by writing a number between 1 and 10 multiplied by a power of 10. So for example, on March 4th, 2012, the US national debt was approximately 15. How do I figure out how to say that number? It's trillion, yeah, because this is like hundreds, thousands, millions, billions, trillions, right? So that's $15,460 billion. It's so hard to say that number and to conceive of how big it is. That's when scientific notation could be handy, right? So if I were going to write this number, there's a decimal point right here at the end. There's always a decimal point at the end of every number. Move that decimal point to the left until it becomes a number between 1 and 10. So where would I put it? Between the 1 and the 5. So this becomes 1.546. And then I have to multiply times 10 to some power, right? And multiplying by a power of 10 moves a decimal point to the right, right? Every time you multiply by 10, the decimal point moves 1 to the right. So I have to figure out how many places I have to move the decimal point to the right to actually make 15 trillion. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places. So I would times 10 to the 13th. That looks like a B. So this is just another way of writing $15,460 billion. 1.546 times 10 to the 13th. So here's an example where we do this for small numbers. The diameter of a typical bacterium is 0.000000241 meters. If I wanted to say this number in correctly, I would have to go, okay, so it's got to be tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, millionths, 241 that's 10 millionths, 241 millionths. Yeah. Yeah. And that's like, it's hard to say. You got to like count what the place values are. So instead, we would say, okay, if I had to move that decimal point to make a number between 1 and 10, what would my number be? 2.41. I would move it, keep moving it to the right until it landed right there. Then I'd be between 1 and 10. So then I got to multiply by 10, right? So my decimal point landed right there. I got to figure out how many places to go back to the left to get my actual number back, right? Yeah, so you got to multiply by a negative exponent because multiplying by a negative exponent moves decimal points to the left, right? So I would need to move 1, 2, 3, 4, 5, 6, 7 places to the left, so I multiply by -7. Or I use the -7 exponent. Yes. Yeah, I think you should keep the 0.41, yeah. Yeah. Thank you. Mm. Yeah, no, I think we should keep it. Yep. Okay, so you've got some activities following this. For the remainder of class, 40 minutes, you're going to work on the activities that start on page 116.